The productivity of wet rice farming. The wet rice fields of Asia are the most productive of all pre-industrial intensive agricultural systems. As the term wet rice suggests, the method involves flooding the fields for most of the growing season. In some areas, the water comes entirely from the natural rainfall of the monsoons, but the water level often is controlled by artificial irrigation. Most wet rice is, therefore, grown on the floodplains of rivers. In parts of Southeast Asia, southern China, and the Himalayan fringes, wet rice is grown on terraced hillsides originally constructed centuries ago. Perhaps the most remarkable feature of wet rice cultivation is the capability of a plot to yield a harvest year in and year out, with little or no need to be left uncultivated for extended periods in order to recover its fertility. Indeed, where the seasonal availability of water is adequate, the same plot may yield 2 and even 3 harvests in a single year, being under almost continuous cultivation. This capability has been attributed to 4 factors: the protection from erosion the water gives the soil, the high water table of the river's floodplains that reduces the leaching of nutrients from the soil, the replacement of soil nutrients by the silt carried in the river's flooding, and nitrogen fixation, the conversion of atmospheric nitrogen into forms usable by plants, from the blue-green algae that live in the floodwater. The chief benefit of wet rice, its ability to grow in the same field year after year, is then related to the practice of flooding the fields and allowing the water to remain throughout most of the maturation period. Despite the advantages of their methods, wet rice farmers must solve problems relating to the management of water, because the proper supply of water at the proper time is so important for a good yield. It is more efficient if storage ponds or tanks, canals, ditches, and other improvements are held and managed communally, because less labor is required to construct and maintain them than if each family owned its own. Water may be stored in small lakes or ponds or captured and held in tanks until it is used to flood the fields. The water level must be controlled fairly precisely while the rice is growing. If it rises too high, the plants will be unable to photosynthesize, and if it falls too low, the benefits of having standing water in the fields will be reduced. Unless the land is naturally flat, the plots, therefore, must be leveled to keep the height of the water constant in different areas of the field. The water level must be controlled by low dikes, usually constructed of earth, which can be easily breached to drain the plot for the harvest. Managing the supply of the water that is so critical in growing wet rice requires sophisticated organization, especially with respect to cooperative labor patterns and rights of access to both land and water. Each family may work its lands on its own, but who will construct and maintain public irrigation works? Who will decide when dikes, dams, ditches, and tanks need to be repaired, and how will the labor to repair them be coordinated? The water used on the fields of one family is not available to other families. How shall the consumption of water be coordinated? Who will get how much water and when? How, in short, will water use rights be determined? In one example of organizing the allocation of water to the fields, the Sinhalese of the dry zone of Sri Lanka draw water from a collectively owned, rain-fed reservoir constructed of earth. All of the cultivated land of a village is in a single area below the reservoir. The entire field is laid out into diked plots of equal size. Each plot receives a fixed amount of water from the communal reservoir, though the number of families working a single plot varies. Poor families must share water rights of access to one plot with other families, whereas richer families have access to several plots. Assigning each plot, rather than each family, the same proportion of irrigation water reduces the chance that a given plot will receive insufficient moisture,